Good morning everyone, I am Christina Marie Campos from SO2B and I'm going to report one problem for our progress check in chemical calculation. So the given problem I have here, 1 kilogram of butane is burned completely with theoretical air. I am going to determine the kilogram of carbon dioxide formed, the kilogram of water formed, the kilogram of nitrogen formed in the flue gas, and the percent mass composition of the dry flue gas, and lastly the air ratio or the air to fuel ratio. So in my assumptions, I have the combustion is complete and the combustion of products contain carbon dioxide, water, and oxygen and nitrogen only. So when we say theoretical air, it is the amount of air that is required to provide the right amount of oxygen for the complete combustion, which is fairly constant on air or gas weight ratio. So in order to get that, we have here the molar masses of carbon, hydrogen, and oxygen. So carbon is equals to 12 kg per kmol, hydrogen is 2 kg per kmol, oxygen is 32 kg per kmol, and the air is 29 kg per kmol. The reaction equation for a 100% theoretical air is here. The butane plus the stoichiometric air coefficient multiplied by oxygen plus 3.76 of nitrogen will yield B, which is the amount of carbon nga kinahanglan ta, plus D, which is also the amount of hydrogen, plus A, which is the nitrogen. So in our diagram, I have kilogram of butane, which is the input, and together with the air, which is 100% theoretical, and yield, which is the product. So the coefficient or for the stoichiometric coefficient for air and other coefficient are to be determined from the mass balance. To get the mass balance, we need carbon is 4 kmol, hydrogen balance 2D is equals to 10, yields 5. So D is equals to 5 kmol if we solve that. And for the oxygen balance, we have 2 sa stoichiometric coefficient is equals to 2B plus D, which yields the stoichiometric air coefficient will be 0.5 multiplied by 2 times 4 plus 5 equals to 6.5 kmol. So nakagets na naman siguro kung paano ko naging kwa. So, the carbon is 4 kmol, hydrogen is 5 kmol, oxygen is 6.5 kmol, nitrogen is 24.44 kmol. Substituting this balanced equation, we can get butane plus 6.5, which is our kagina nga stoichiometric air coefficient, multiplied by 0.2 plus 3.76 of nitrogen, which yields 4 carbon dioxide plus 5 water plus 24.44 nitrogen. Pamuni sa kagina, ang aton nga B, ang aton D, kag ang aton nga E. Okay, let's proceed. After that, the mass of each product and the total mass which are produced are as follows. So, the N variable represents the kmol and the M variable represents my kilogram per kmol. And here is the atomic weights of each element from the periodic table. So the mass of carbon dioxide formed will be equals to the number of carbon dioxide multiplied by the mass of carbon dioxide, which is 4 kmol multiplied by 44 kg per kmol. Cancel the kmol, we can now get the 176 kg. Same with water, nitrogen, and for the total mass, we need to add these values, which is 176, 90, and 684. To get the value, we now have 950 kg, which is the mass total. Wala ko lang din nasulat, sorry. We can now get the mass composition of carbon dioxide, water, and nitrogen, or which is our dry flue gas. In getting the percent composition in dry flue gas, we need to divide the mass of carbon dioxide divided by the total mass of dry flue gas multiplied by 100. We can have this equation will be equal to 18.53. Same with the water, which is 90 kg divided by 950, which is our total mass of dry flue gas multiplied by 100. And same with nitrogen, which is 684 kg divided by 950 times 100, we can get 72%. So if we add this 18.53 plus 9.47 plus 72, we can get 100%, which is kagina sa aton assumption, ang aton nga theoretical air is 100%. And then we can Now get the ratio of air to fuel by substituting the values we have. So the ratio of air to fuel is the mass of carbon dioxide divided by the mass of butane, which is equals to 4 times 44 kilogram divided by 1 times 58 kilogram will be equals to 3.034 kilogram of carbon dioxide per kilogram of butane. And the mass of air required per unit of fuel burned is the mass of air divided by the mass of butane will be equal to 6.5 times 4.76 times 29. Ang amo nga mga values, amo ni kaginaging pangsaw. Divided by 1 times 58 kilogram, which yields 15.47 kilogram of air per butane. So, after getting these values, we already identified the kilogram of carbon dioxide that is formed, the kilogram of water formed, and the kilogram of nitrogen in the flue gas. We also get the mass composition of dry flue gas and the air to fuel ratio. And that will be all. Thank you.